Greetings to all the viewers. Now we are going to conduct the session based on Aldol condensation reaction. This is the part of organic named reactions which is retrieved from the textbook of organic named reactions written by Dr. Kavita Kottireddy Kota. The sessions whichever conducted based on these named reactions available at the channel called World of Competitive Chemistry. Not only that, whatever kind of conceptual representation of chemistry, examination point of view of chemistry, you can go through World of Competitive Chemistry. So many series of sessions available. The right choice for your serious preparation towards the exam or else research or else academic perspective as well, right? Let me continue with the named reaction called Aldol condensation. Aldol condensation in the organic chemistry involves condensation of carbonyl compounds accompanied by the alpha hydrogens at its core. Alpha hydrogen presence is the essential element in this aldol condensation process. Will occurred beta hydroxyaldehyde, beta hydroxy ketone known as a aldol condensation. Subsequent dehydration gives conjugated enone. Aldol condensation reaction is a fundamental organic reaction that involves the formation of carbon-carbon bond between the alpha carbon of carbonyl compound, usually aldehyde or ketone, carbonyl compound of enether. This reaction is important both in the synthetic organic chemistry and biochemistry as well, right? Aldol condensation very essential to introduce the new carbon-carbon bond extended carbon chain. You can notice beta hydroxyaldehydes are the common compounds originated. The essentiality will be presence of alpha hydrogen with respect to either aldehyde or ketone. Let me introduce the reaction. 2 moles of acetaldehyde, if treated under base catalyzed conditions, there is a formation of beta hydroxyaldehyde as the final product, butanaldehyde to 3 hydroxy butanaldehyde as the final product if you are taking acetaldehyde as a starting material. And the same reaction is represented in the systematic way, where we are taking acetaldehyde of 2 equivalents and treated with alkaline conditions like sodium hydroxide under aquatic conditions, and the temperature to be lowered at 5 degrees centigrade, and you are able to accord beta hydroxyaldehyde as the final product, and the yield is some comparatively low. And here is the new carbon-carbon bond origination is possible, and a new OH bond is also generated, being aldehyde group now turned into hydroxyl, so that OH bond formation is also the commonality over there. Already existing ketonic pi bond will be broken, and carbon hydrogen alpha hydrogen carbon bond is also broken. This is the kind of criteria for this new bond formation and simultaneous old bond cleavage. Journal of American Chemical Society in 1914, this work got published at 36 volume and 530 to 537 page numbers. You can access this content from this Journal of American Chemical Society, and this is the novel reaction called aldol condensation, right? Mechanism. How can we proceed through the mechanism for the aldol condensation? It is the stepwise manner. Initially, presence of alpha hydrogen is the essentiality. We already noticed that one. And alkaline conditions like a strong base to be treated in order to extract this hydrogen. Hydrogen is pulled towards hydroxyl functionality, so that a generation of carbene ion taking place. Immediately carbene is enolized with respect to this carbonyl functionality, so that a resonance stabilization formation is possible. Enolate oxide is the intermediate. That to be proceeded for either aldehyde condensation reaction, and aldehyde functionality directly participating in the reaction with the carbene intermediate, so that here the new origination of the carbon-carbon bond, so that long chain organic compound will be originated. Whenever this carbene is attached over the carbonylic carbon, pi bond is shifted towards the oxygen, so that you can experience oxygen negatively charged one. This negatively charged oxygen able to bind up with the aquatic proton. Aquatic proton will be taken over there, so that protonation giving rise to the compound called beta hydroxyaldehyde. With respect to functional group, exact adjacent position is called alpha, and next position is called beta. At this beta position, the OH group is resided. Hence, we can say beta hydroxyaldehydic compound is originated, right? So this is the way kind of mechanism is clearly manifested. Initially, alpha hydrogen must be present, base able to take out this hydrogen. Alpha hydrogen is acidic in nature, being electron withdrawing group, able to generate the electron deficit over this compound, so that here strongly electrons are taken over there, so loosely bonded H plus is easily removed towards the alkaline medium. That's the reason why origination of carbene ion is possible, which is a resonance stabilized enolate formation. Later, another aldehyde to be treated by the process called condensation, and here is the new carbon-carbon linkage you can notice in between. And here, wherever aldehyde group is there, that turned into a oxide form. Further protonation from the water molecule giving rise to a hydroxyl. With respect to aldehyde, it is located at the beta position, so that beta hydroxyaldehyde is the final product over there. This is said to be Aldol condensation. Let me give the examples pertaining to Aldol condensation reaction. Consider Aldol condensation between the two molecules of acetaldehyde called ethanol in accordance with the IUPAC nomenclature. So here ethanol to be taken hydroxide if added, here the carbon origination at the terminal carbon atom, being it is acidic in nature, alpha hydrogen to be removed, so that here water is the byproduct. In continuation, this carbene able to bind up with another mole of aldehyde, so that here the carbene to carbonylic carbon bonding giving rise to beta hydroxyaldehyde, which is 3-hydroxybutanol as the final product. In general, you can designate aldol. This compound is said to be aldol. Right. Dehydration. Simply, whatever compound generated further go for dehydration process. Whenever a water molecule removed from these two carbon atoms, like second carbon, third carbon, under basified conditions, so that alpha beta unsaturated carbonyl compound will be originated. In terms of acetaldehyde, the product originated is said to be crotonaldehyde. The 4 carbons with alpha beta unsaturated carbonyl is said to be crotonaldehyde, right? This is the simplest schematic representation with respect to ketone and another ketone, aldehyde or ketone to be taken under basified conditions. Here is the origination of a conjugated aldehyde or ketone. Conjugation matters over there for their stability, so that existence of the product is more facile, and that is progressed towards the product formation because of the stability of this conjugation, right? So let me go for the simplest example for this aldol condensation reaction. I'm taking CH3C double bond with CH2CH3. This is the kind of typical ketonic compound. Let me treat with acetone one, so that base is the kind of catalyst able to facilitate this kind of condensation process. In between this alpha carbon atom and this alpha carbon atom, the reaction, alpha carbon atom and carbonylic carbon atom, new bond formation originated, and simply you can notice the double bond by the water as a byproduct. Here is the alpha beta unsaturated carbonyl compound origination whenever two ketones are supposed to be treated. In terms of the reactivity pattern about the aldehyde and the ketone compatibility factor, or else reactivity comparison, if you go through, obviously aldehyde will give the higher yield over the ketonic product, being a steric obligations matters in case of ketones. In order to remove the proton, in order to go for the condensation further, so that ketones are somewhat less reactive in terms of aldol condensation with respect to aldehydic functionality, right? So this is also the kind of example you can notice where alpha beta unsaturated ketone is generated whenever you are taking CH3C double bond with CH2CH3 treated with acetone. This is said to be what? A butanol acetone to be condensed by aldol, giving rise to alpha beta unsaturated ketone as water eliminated as byproduct. In order to understand the mechanism for this ketone aldol condensation, let me go with the methyl ketone catalytic hydrogen shift taking place, so that here enolization is accomplished over there. And aldehyde is supposed to be treated with this one. So here the bond delocalization taking place, carbene able to bind up with this carbonylic carbon atom. You can notice the new carbon-carbon linkage. This supposed to be dehydrated in between this alpha and beta carbon atom, so that here conjugated system is originated. This is the way ketone is supposed to be go for the aldol condensation process. What conditions will facilitate the kind of reaction? They are fissile. Basic conditions are more susceptible for the removal of proton from the alpha carbon atom, acidic proton to be removed, so that bases like hydroxides, alkoxides, lithium diisopropylamide, all these are the suitable bases in order to accomplish Aldol condensation reaction. Even acidic medium is also required for the protonation. Simply, acids, although mechanism involves the enolate, intermediate enolate ion formation is possible. Acidic conditions are required at the completion of the reaction. Let me give the example pertaining to aldol condensation. Here is the kind of ketone called a butane. Lithium diisopropylamide strong base is taken in order to achieve this carbene intermediate. Later, one mole molecule of same molecule is treated, and here is the formation of hexanone. 4-hydroxyhexanone as the final product. This is the aldol condensation. Let me go for acetaldehyde, which is already known to you. Sodium hydroxide is the driving base over there in order to pull the acidic hydrogen from the adjacent carbon atom, so that here protonaldehyde as the final product. After the elimination of this hydroxyl as well, protonaldehyde will be originated. Let me go for the cyclic compound. Ring compound is also involved in this aldol condensation. Furfural is taken where the aldehyde functionality you can notice. And here is the cyclohexanone. Cyclohexanone is having the alpha hydrogens, but here the provision for alpha hydrogen is not observed. Still, the molecule go for the aldol condensation under basic conditions, so that you can notice the hydroxyl functionality bridging between that furan ring and cyclohexanone ring. This is the way aldol formation is possible through the same mechanism. So after observing these many examples which are proceeded with aldol condensation, let me go for the application perspective. Applications of aldol condensation reaction in pharmaceutical field, natural products, and biochemistry as well, right? So here the acetaldehyde keto mode can be taken over there, that enolized like this, and another acetaldehyde to be treated. Aldol addition, product formation, and the conjugated compound formation taking place. This is the kind of pharmaceutical application we can say, right? So they are utilized under pharmaceutical conditions. Synthesis of complex molecules. Aldol condensation is a versatile mechanism pathway for the synthesis of complex natural products, even pharmaceutical compounds as well. Same mechanism is applied in order to build, in order to develop the carbon chain, in order to complexify that compound in terms of natural products and pharmaceuticals as well. Industrial chemistry, not only the pharmaceutical but also bulk scale synthesis process utilizes large scale chemical synthesis through the aldol condensation mechanism. Alpha beta unsaturated carbonyls formation, cyclic structures, Robinson annulation taking place as a part of these aldol condensation process. Pharmaceutical intermediates, fragrance, and flavoring industry is also considered as the application perspective for aldol condensation. So, pharmaceuticals, obviously, whatever generated by this aldol condensation is having effective curative property, treatment for the various diseases like microbial and injuries, and also nervous system related kind of problems will be settled by means of this kind of pharmacophore originated from aldol condensation. And the fragrant industry and the flavoring industry is also taking the advantage of aldol condensation to establish the kind of organic compounds. In continuation to aldol condensation, there is a crossed aldol condensation. Crossed aldol condensation means in order to compare the aldol and crossed aldol, aldol condensation is symmetric. Whatever aldehyde taken and the same aldehyde another can be taken, both are identical or supposed to be condensed. That is simply said to be aldol condensation. In case of crossed aldol condensation, either different unsymmetrical aldehydes to be taken. One aldehyde may be one kind, another aldehyde is another kind, or else one aldehyde, another ketone to be blended. This is the manner there is a kind of crossed aldol gives rise to a mixture of products, because alpha hydrogens may present in one component, alpha hydrogens may not present in second aldehyde compound. So there is also the kind of provision to get rid of the final product. This is the way crossed aldol meant for unsymmetrical product formation, unsymmetrical condensation process taking place More the applicability you can notice by means of this crossed aldol condensation. Aldol condensation versatile, powerful in the organic synthesis, enabling complex carbon skeletals in terms of pharmaceuticals, in terms of materials, in terms of biological things as well. Right. If you want to know about the cross-aldol condensation, unsymmetrical condensation, one is the acetaldehyde to be taken. This is 1 mole of acetaldehyde. Enolation you can notice, so that enol mode is generated. This is supposed to be treated with another aldehyde, not exactly same. Rather, you can go through formaldehyde where alpha hydrogens may not be present. One of the material is alpha hydrogen containing acetaldehyde. In either one alpha hydrogen lacking molecule, these are supposed to be blended called crossed aldol. So that you can notice the new carbon-carbon bond origination in between, and later on dehydration taking place, giving rise to alpha beta unsaturated compound. This is a conjugated one. So this is an extended application in terms of that aldol condensation called a crossed aldol. Conditions for the aldol condensation. Aldol condensation is carried under certain conditions only. Only carbonyls with alpha hydrogens can form enolate and enol and participate in this reaction. The compulsory condition to satisfy aldol condensation is alpha hydrogens must be present within the molecule. Aldehydes are usually more reactive in comparison to the ketone. Just now we discussed, in terms of a stereochemical perspective, aldehydes are a great affinity towards this aldol condensation rather than ketone. That's the reason why aldehyde product formation is higher extent and higher research carried over the aldehyde aldol condensation over ketone, being these are rigid in nature. They are limited for aldol condensation. Crossed aldol, avoid the mixtures using. Whenever crossed aldol condensation taking into the consideration, not only the expected one product, rather you can achieve the more than one product in the mixture form. This is the way crossed aldol will give the mixture of compounds in extendable application perspective. This is the way we successfully completed that named reaction called aldol condensation and crossed aldol condensation. In the next session, we will continue with allylic rearrangement. Thank you very much for your patient listening. Those who are serious and more dedicated towards the chemistry exploration, research, and academia, so the kind of channel World of Chemistry, World of Competitive Chemistry is very much helpful for your preparation and your better understanding the complex topics. Those topics got simplified and gave into the complete picture about the entire concepts in the elaborated in-depth information format. And definitely you will enjoy the session if you're curious about the chemistry. Thank you one and all for your patient listening.